All right, good afternoon, class. We're going to start lesson 2, which is properties of just parallelograms. These are the special type of quadrilaterals that have two sets of parallel sides. At first, we're going to talk about the sides and the angles, and after that, we'll get into dealing with their diagonals on the back side of the notes. So first of all, Theorem 6.1 states that the opposite sides of a parallelogram are congruent. And you can see here that this side is congruent to this side. This side is then congruent to that side, as marked. While we're talking about sides, we should also talk about the angles. So if I were to label this A, B, C, and D, we will see that A and B are what we call consecutive angles. A and C would be opposite. So A and B, consecutive. A and C, opposite angles. Now, what does it mean to be a consecutive angle? Well, consecutive angles are angles that share a side. As I said, A and B are consecutive angles. If you remember anything from our talk with parallel lines and being cut by a transversal, say I have these two parallel lines, I have a transversal, we may have to turn our paper, but if I label this A and B are on the same side of that transversal, so we say they are same side interior angles. And if you remember from our talks about parallel lines and that transversal same side interior angles, they are going to be supplementary. And supplementary means they add up to be 180 degrees. Alright, so let's see if we can use that information to calculate some angle measures. It says to find the measure of angle S. Measure of angle S is right here in the figure. And measure of angle R is 112 degrees. Well, S and R are both on the same side of that parallelogram. So therefore we can say that 112 plus, let's call this X, equals 180. We can subtract off 112. X is equal to 68 degrees. So if this angle is 68 degrees, and again we have parallel lines, we know that this angle S and this angle T are also same side interior angles, so this one must be 112 degrees. And if these are same side interior angles, this is 112, this one must be 68. So what do you notice about these opposite angles? Hopefully you're saying congruent. So we can say that opposite angles are congruent within a parallelogram. And that's what Theorem 6.2 states. that opposite angles of a parallelogram are congruent. This angle is congruent to the angle across from it. Alright, so let's move on to example number 2. Example number 2, the first one's asking us to find the value of x when we're given sides. This is 3x minus 15. This is 2x plus 3. If we have this parallelogram, and there's a figure here saying it's a parallelogram, PQRS, then we have to find QR and PS. Well, going back to theorem 6.1, it says opposite sides of the parallelogram are congruent. So these two sides are congruent. 3x minus 15 equals 2x plus 3. We're going to subtract off 2x. And I'm going to add 15 at the same time. So x equals 18, just because I had limited space. But we need to find QR and PS. So QR states 3 times 18 minus 15, or 2 times 18 plus 3. Both of these should equal the same thing, which is 39. And at any point, if I'm going too fast, please feel free to pause the video. As I told you guys before, it's very hard to give notes to a class that is completely empty. And it's hard to have wait time, and obviously I'm just going to keep going, and you guys can, like I said, pause it, or you can even go rewatch it if needed. Alright, so moving on, example 2, letter B. Here we have something to do with the angles. And we're looking at this angle and this angle here. And these are not consecutive angles, these are what we call opposite angles. And opposite angles, according to theorem 6.2, says the opposite angles of that parallelogram are congruent. So let's go ahead and set 3y plus 37 equal to 6y plus 4. What should I do first? Hopefully you're all saying let's subtract 3y. If you chose to do something else, that's okay, as long as you're following the rules of math, it will work. So we have 37 equals 3y plus 4. I'm going to subtract 4 now. So I have 33 equals 3y. Therefore, 11 equals y. Now we need to find all angle measures. In order to do that, we need to then plug in y into that angle. So 6 times 11 plus 4 is going to give me 70 degrees. We know that opposite angles are congruent of that parallelogram, so this is also going to be 70 degrees. Now we got to figure out what is, say, x up here. If this is 70, these are consecutive angles, and consecutive angles are congruent. I'm sorry, consecutive angles are supplementary. So x plus 70 equals 180. So we subtract off 70 from both sides, and x is equal to 110. So this angle is 110 degrees, and therefore this angle is 110 degrees. And obviously the figure is not drawn to scale. The measures don't look like the angles that are there. but just because it looks that way doesn't mean that it's not right. Okay, so let's flip it over. Let's move on to the second objective that deals with diagonals. And we talked about diagonals before. Diagonals were talked about when we did concave and convex figures, and we said that it's a segment that connects two non-consecutive vertices. So when we're talking about parallelograms, it's a segment that connects from opposite angle to opposite angle, right? That vertex to the opposite angle vertex. And the cool thing about any parallelogram is that the diagonals will always bisect each other. And remember, bisect means to split into half. So it happens at its midpoint. Therefore, we get two congruent segments. Alright, so let's move on. Let's see if we could do some math with this. As always, label your figure. We know that KM is a diagonal of this parallelogram. KM is equal to 38 units. And TM is this little side is equal to 2x minus 5. But TM is, since it starts from its midpoint over, is going to be half of this side, 38. Or we can say that the whole distance, 38, is going to be equal to 2 times 2x minus 5, because that is going to be half of that. We can distribute here. 38 equals 4x minus 10. Let's go ahead and add 10. 48 equals 4x, or x equals 12. All right. EU is 18, so that's the half part. And SU is that 5x plus 1. So we need to double the EU to get to the entire diagonal. So it's 2 times 18 is equal to 5x plus 1. 2 times 18, 36, equals 5x plus 1. You subtract 1 from both sides, you get 35 equals 5x, or x equals 7. Now if you look at example 3, number 3, we have A's and B's within this figure. So we have to figure out A and B. These are two diagonals of a parallelogram, so this side, or this segment is congruent to this segment, and this is congruent to this. So we can state A equals B plus 2. And I can also state that A plus 10 equals 2a minus 8. Well, which one of these can we solve for first? We have to figure out one of the variables. Hopefully you're talking about this angle, or this equation here. We can solve for a, and then we can plug it in to figure out what b is. So I'm going to subtract off a on both sides. 10 equals a minus 8. And if I add 8 to both sides, 18 equals a. So let's take this now and plug it in to see what b is. 18 is equal to b plus 2. So you're going to subtract 2. b equals 16. And the last theorem that we have to talk about, which is a pretty simple one, it's the theorem 6.4 that says if 3 or more parallel lines are cut off, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if you look at this figure, here's a transversal because all of these lines are parallel to each other. This transversal cut equal segments of 2 units, 2 units, 2 units for going down here. That means if you draw another transversal somewhere else, that if this is 2.5, this is going to be 2.5, that will also be 2.5. And if you drew another one and they were a different segment length, then all of those segments would be congruent. So we need to find FG. FG is 2.5. G to H is also 2.5. E to H, so this is 2.5 plus 2.5 plus 2.5, so that should be 7.5. My math is correct. And then A to D is going to be 2 plus 2 plus 2, which is going to be 6 units. Sorry. Alright, well that's that. You guys will have some work to do. You have a worksheet to work on. It's kind of from the book. Some of it's not. But again, if you ever need any help, you can always refer back to your book. We are on like 294, 295. There are books in the class if you want to borrow them, or you guys have a book for yourself at home. Alright guys, hope you're doing okay, and hope to see you guys soon. Take care.